Hey everyone, my name is Rowan. I'm a software craftsperson at Codurance, and today I'm going to show you 10 direct ways you can contribute to open source software. Now, if you go and search online for this kind of stuff, you'll get so many resources telling you how to find a project to work on, but there's not a lot of information telling you where to get stuck in once you've actually decided what you want to work on. So the stuff I'm going to show you today is going to show you exactly where you can get stuck into the code and give you ideas on how you can start contributing. So I'm going to make an assumption that you're using GitHub for this. It's pretty much the #1 source of open source software in the world, so that's where we're going to be looking for our project. Now, I've chosen a project for this. Like I said, I'm going to assume that at this point you've found the project that you want to work on. I've chosen one as an example called DevToys, which I hadn't actually heard of before. It's pretty cool. It lets you add loads of extra functionality that a software developer would want all in one easy place, so converters, encoders, and different formats. It's really cool. There'll be a link in the description below, so you can check this out if you want. Now, hopefully the developers of this don't mind me making a video of this. Obviously, I'm showing you where you can improve on this, but it's open source software. The nature of it is that people contribute and share ideas and change it. And if there's anything that you think looks sort of too awful, do bear in mind that it's actually, you can see from some of the check-ins, a bit out of date. They are actually working on a version 2 of this, so they're not keeping this version up to date. So bear that in mind. So we're going to start off with what I've noticed to be the #1 way that other places tell you to get started with projects. And actually, in lots of cases, this is the only way they really sort of hint at you starting off. And that is by reading the documentation, which is actually a pretty good place to start. We're not necessarily interested in just reading the documentation to see how the project works. We want to look through and see, is there any documentation we think is missing? So some of the things that we want to look for: an explanation to what the project is, how to install a project as an end user, or API usage instructions if the product is built for a developer, how to install the project for a developer to work on themselves, or maybe any sort of implementation specific things like architecture diagrams, user stories, quality assurance approaches. It kind of all depends on the project itself and how in depth they want this documentation to go. So now we have an idea of what we want to look for. Let's go through the documentation and see if we can find anything that we think might be missing. So we've got an introduction. It says what the project is and what it does. This could maybe be tidied up a little bit. It's sort of a long list. We have an image here, which is a little bit unclear and doesn't really say what it is anywhere. Prerequisites, how to get it, lots of different ways you can install it. Might not be super clear that you just need to do one of these, I don't know. Sort of lots of extra license things. The thing that actually stands out is this contributing bit, which is directly relevant to us. So we've got how to sort of raise some features, how to build and run it, which is good because that's what we want to know as developers. There's also a little bit here about the main architecture, how some of this stuff works. Code style, that's pretty helpful, especially when you're contributing to open source. You want to know that what you're doing fits into the rest of the project style-wise. So overall, it kind of contains everything that we would want to see. The main change I would want to make to this is breaking some of this stuff up into separate files and maybe having a nicer navigation menu. So that could be the very first thing that you do jumping into this project. So now we have a bit of an idea on how the project works because we've looked through the documentation and maybe you've contributed to the documentation. The next thing on my list is to actually go and look at the issues and the discussion sections here in GitHub. Go to the issues. We can see a whole list here of things that people want to suggest, basically. We can see from this one that actually there are enhancements and bugs, so this isn't just issues in this project, it's used for both improvements and issues. There's all kinds of tags that can help you sort of identify what it might be about. Enhancement, if it's been triaged, you might want to only take things that have been triaged, which means either some other people have got involved, it might be people directly related to the project, owners of the project. It depends really what the owners of the project want. If they're comfortable with members of the community triaging each other's problems, that might be okay. So we can scroll through this list. And the very first thing I would look out for is that any of these titles stand out as something that interests you. So to me, I like the sound of this. Go back to list of tools on back mouse button click. So let's click in there. It sounds to me like it's going to be pretty easy. It sounds quite straightforward in what they want to do. So what we want to do next is go and check the actual description of it here. We want to make sure it's clear what they're actually asking for here. This one's quite straightforward. It's pretty easy to determine what they want. They want the mouse button 4 on mice with extra keys to go back, and it does that on lots of other apps. So it sounds quite straightforward, and they're specifically asking it to go back to the list of tools if you've just opened a tool. It sounds straightforward. Sometimes there are extra things you might want to take into consideration. It sounds easy. They just want a back button to go from one place to another. What the ticket might actually be asking is, do I have to implement the back button feature for a mouse for the entire app for this to work? Depends what's already there. So just give some of your own extra consideration when thinking about what these issues could be. If we go back, let's look for a bug. And I like the sound of this one. URL encoder should treat new line as this. So the main thing we're looking for with bugs specifically, is there a clear description of what the problem is? Most importantly, are there steps to reproduce it? Because if you can't reduce the problem, it can be really hard to figure out how to resolve it. And here's somewhere actually that triaging really makes a difference, because some random person could have come and put this on the internet and it might look all good and, we've got all the steps to reproduce what it should be doing. But without other people feeding into this, you don't necessarily know that what this person's saying should happen is actually what should be happening. This could be completely wrong. Now we've looked at all the issues, we can actually go up and let's take a quick look at discussions. Now, discussions are kind of a bit broader. They're not necessarily looking for an outcome. These are kind of just chats. So you can find things here you want to do, but you're probably going to have to dig a bit deeper into what the discussion's about, maybe contribute to the discussion yourself and see if you can sort of gain these ideas or work items for the project out. Based on that sort of nature, it's probably going to be enhancements for the project, because if it was a bug, they would just put it in the issues section. And now the last thing we're going to look at before we start getting onto some of the more technical stuff is actually quite an obvious, easy one. Now, if you've gone through all the effort to identify which project you want to work on, you're probably quite attached to it in some way. So one of the main things that I would suggest to find ways you want to change it is to literally just sit and play with it, have a go, find issues from a user perspective or things that you wish were there, and think about adding them yourself. Probably want to quickly go over to the issues section first, just to make sure that no one else is already talking about this or in the middle of implementing it. So I'm going to type in and search for converter. Let's say that I want a new type of converter, and I could just have a quick look through here to see, does it already exist? Is it worth my time doing? So now I've had a bit of a look around the project and what kind of state it's in. The next thing that we're going to do to help us dive further into the code is to actually get this locally. We could go and click around on here and look in all the code on GitHub to find out what it does, but nothing really beats being able to play with it in your IDE of choice, where you can move around it, you can run it and debug it, do everything you need. So to do that, in the main project page, we're going to go over to the big green button that says code, and in this clone section, we're just going to click on this copy link. And now over here in my terminal, I'm going to do git clone and paste the link in that we just copied and hit enter. Now for me, I've already got it installed, so it's fatal, it's already exists. I didn't want to delete it and redo it for this because this project's like 4.5 gig, but let's assume I've just cloned it into there. So now I open it in File Explorer and I'm greeted with all this stuff in the repo. It's a bit overwhelming, but actually I remember from before that we have a contribution section that tells us how to get involved as a dev. So we go down and find it. We've actually got some instructions here on how to run it. And the important one here is we need to run init.ps1 to restore some dependencies. Init.ps1 lives here, and I'm just going to right click on it and run with PowerShell. I'm not actually going to do it here because I've already done it, but that sets up a load of dependencies, takes about a minute to run on this project. And assuming that that's done correctly, everything now for the project should work. So looking at all these things, I would assume it's source, and actually I think the documentation tells us it's source to click on. So we're going to go into here, and I see the solution file. Now, here's a little bonus tip for a way you can improve the project. When I first ran this is just an image at the moment, but this is what the IDE gave me when I first opened it, saying that the .NET version was too old compared to the ones I've got on my machine. So it could be that you find in your projects, they might be using a really old version of the language or even any of the packages or runtimes for the project. So you could investigate modernizing them, bringing them up to date as an extra way you could contribute to the project. Okay, so now we're in the project. And when I first got in, it had all this stuff open for me. So in Visual Studio, we can just click on collapse all, and it will minimize everything. And then we can go through it and discover things at our own pace. One of the very first things that you'll probably want to do is build the solution, just to make sure that you've set everything up properly and there's nothing missing. So all of the ways that we're going to look at contributing going on from this, we can make sure they're going to work because we know the project works itself. And it's probably going to take a couple of minutes to build just because the way it works under the hood does quite a lot of stuff. And there we go, it's finally built. There are a few warnings. They were mostly things we can ignore or things to do with the release, which we don't need to pay attention to right now. So the next tip on our list, number 4, is actually trying to find ways you can improve the testing on a project. If a project doesn't have any testing, I mean, that's a really easy place to start because you can start adding it in. In this case, we've got a folder here called tests, and I'll expect a test project in here. There we go. And so you can find tests in here and just see if you can notice where things are missing. It might be functions that don't have anything on. There might be sort of bad paths. So many people add tests for how it's supposed to work with a few considerations, but there are so many bad paths and edge cases that you could test for which they might not have thought about. So we're going to look in this, and I'm going to open the dev, and I'm kind of hoping that the test project reflects the code itself. And we're going to go in here because I actually know where it lives. It's a few layers down, which is a bit confusing. But once we look in here, we can see that these folders pretty much match up with these ones, although there's a lot more stuff here, so that's already identified a place that you might be able to add more tests. And we're going to go into the base64 helper tests. So what this is doing, it's checking if all of these strings it's taking as inputs are base64 or not. So we've got a load of things here that sort of look base64-ish and some sort of null stuff. And what I'm going to do first, I'm actually just going to run these tests to make sure it passes and to make sure that these tests run just by themselves. They should be unit tests. They shouldn't rely on any other part of the system. If we take a look at the function itself, it's just doing a load of sort of basic string manipulation and checking. So there's no reason for it to look at other parts of the system or rely on any other services. So we're going to go to our test explorer here. So we're going to make this a bit bigger. And we're going to find our tests, and I've already run them before, but let's just run them again just to demonstrate and show that these are all still passing. Now we can see that the tests have passed, and actually running the test threw up another couple of bonus ideas that we can do in ways to contribute. What I didn't really show was in the background, it actually sort of fired up an entire kind of mock or fake version of the application to run in order for these tests to be run. And based on what we saw in what the function was doing, there's no reason that this needs that whole system to be fired up in order to just check this little bit of code works. So 2 things you could look at improving. 1, it could be that it's configured wrong. There's some sort of dependencies that aren't really required in certain places. And you could look at improving that whole system and speeding the test run up. The other thing is, it could indicate that there are actually integration tests in here. Now, these aren't really separated between unit and integration tests at all here. There is a folder called UI here. Maybe that's got some UI tests in it. No. So, I mean, another avenue is just because it's got unit tests, you could go and add UI tests and integration tests. But if it does contain integration tests, it might be worth going through and sort of separating out which ones are unit tests, which ones are integration tests, because they want to be run in different ways for different reasons. So those were just 2 quick bonus tips I found there. But if we go back to our main thing, what I want to do is I want to look at all this and say, okay, you've got these strings here. I'm going to duplicate that. And I'm actually going to enter a load of rubbish like that, because I expect that to not be base64. And they haven't got any tests to just sort of check if complete junk isn't there. And now when I run this, I expect it to return false. I've already added some benefit to the project by adding a type of test I didn't think of. If the test fails and it comes back with true, it means the code underneath isn't doing the right thing. And if the whole program crashes, it means they haven't handled a bad input like this properly. So there are loads of different things that we could find here that could help us contribute more. So I'm just going to run these tests again. And when you run tests this way through Visual Studio, running them that way just actually picks it up as a new test. So I will have to run that again. Let's just run that one by itself. There we go. The test did pass in the end. And running it again really highlighted how much benefit this project could get by speeding up the whole process of just running simple unit tests. So we've got a few different ideas there of way we can improve tests, looking at separating out different types of tests, adding in sort of bad path tests, but also just digging through the code and having a look at what's there and what it's doing can help you figure out what tests might be missing. So we've looked at a few different ways we can find and add our own tests in. For the next thing on our list, we're actually going to take that a step further. We're going to use code coverage tools to find out how much of our project is actually covered by tests. Tools like this will literally narrow down for us and tell us exactly where tests are missing in our project and give us ideas on what needs to be improved. And it will also tell us how many tests there are for certain functions versus how many tests there aren't. So you can kind of see which ones have already got decent testing and which ones really need to be improved. Now, for this project specifically, I don't know if it's because it's not expecting Visual Studio 2022 or it's because something's out of date. It will not run the test coverage tool I want to use on this. So I'm going to quickly flip over to a different project of mine for this example, just to show off what I want to show you. And here we have a different project of mine. This is just a demo for something else, but we're going to use this to demo off the tool I want to show. The tool I want to show is actually the built-in one with Visual Studio Enterprise. We go up to Test at the top, and we'll click on Analyze Code Coverage for all tests. It's going to go through every function I've got and analyze how many paths through the function the tests are actually covering. So it looks at inputs and outputs and tries to figure out if you've done enough to say this is fully covered in tests. There we go. It took some fiddling for some reason. I think I just had to build the tests again first. But this is what I want to show you. In here, it shows us all of the code that's covered and all of the code that's not covered by tests. So we want to dig into specifically the RPG Shop DLL, which is the main project, not the test one. And let's make this a little bit bigger. We can start looking into where we're missing tests. So this one here, main application, 197 tests not covered compared to the 44 that are. So we can dig down into here and see specific classes that are missing tests. So one we've got called SQL database, no tests covering it, and 115 it's identified missing. So we can look down in here and it sort of identifies for us for each function how many tests it thinks there should be based on the inputs and outputs. Some of the test coverage tools will give you a percentage of how much is covered, and some of them will actually tell you what it thinks the inputs and outputs and things it's missing are in order to get full test coverage. So it might tell you, oh, you haven't checked if null is passed in here, or at some point I'm expecting this to be passed out of the test. Or sometimes it identifies things that are going on in the function and says, well, you haven't accounted for what happens if this gets hit or this doesn't get hit. So there's all kinds of things it looks for. And from here, we could take one of these, let's say get item by name. And now we could just look at it and start thinking, how could I test this? This has no tests, so there are all kinds of things I could do. What if I pass in a name? What if I pass in like null or empty? What if some of this stuff in the middle doesn't work properly? There's so many things it could be, and with this tool, because it doesn't go super in deep with it, you just have to play around and think, what can I add? So for the next thing on our list, we're going to flip back over to our DevToys project. Now, we just looked at how we can use tools to look at the code coverage for our project. Now we're also going to think about what tools can we use to look at the performance of our project. So number 6 on our list is performance analysis. What this means is we're going to look at how long our project or different parts of our project take to run, and we can see if there's any way we can improve that. There are all kinds of different tools we can use to do this, all the way from sort of individual function testing to check in sort of one small unit by using something like benchmark.net and C#, all the way up to like full system reporting, analyzing how the entire project is running. We're going to look at something that sort of meets these two in the middle a bit. We're actually going to use the Visual Studio built-in performance analysis tools. So if I go up to debug and we click on performance profiler, and it will give us a load of things we want to look at. So we can look at application time, memory usage. I'm going to tick CPU usage for this, sort of some file stuff, some event stuff. By default, it's going to run on our project. You can also change the target, and you can attach this to processes that are already running, which can be really cool because you can like use this to analyze the public methods called in DLLs and stuff like that. We're just going to hit start at the bottom. Just like when we were testing with this project, it's going to take a couple of minutes to build. And now it's running, and this app will actually kick into life. This is the application itself running because it tries to get an accurate reading of how the app would actually work. We could click around a bit. It could help generate some extra stuff. Doesn't really matter too much. You'll see here in the background that it's actually giving us a graph of how much the CPU has been hit. You let this run for however long you want to analyze the application for. This will be fine for us. We hit stop collection. It'll take a couple of seconds to prep the results. And now that's run, we get a screen like this. So this is the timeline and the CPU that's been used over time. We go down here, we actually get the amount of CPU usage that different functions have called compared to the amount of total CPU usage that the application itself has used. We can actually click on stuff like this, and this will start letting us drill down into all of the different calls under that function, and we can see here what percentage they have of that function. So if we expand one of these, it's kind of going to give us something similar to a reverse stack trace, and we're able to see in here which bits of our functions are calling really high amounts of CPU usage. So by going through this, you can identify which of your functions are using a lot of CPU and potentially need to be looked at in order to be sped up. This is really, really useful if you're running something on an operating system, because if it's slowing down anywhere, you can find out exactly how the CPU is being hit and affected by your application. And again, this is just one of the tools you can use. There are so many different things, and depending on which framework and language you're using, the tools you use to analyze your performance might look completely different. But hopefully this gives you an idea of some of the stuff you might be able to do. So the next tip on our list is actually to use some static code analysis tools. Now, what they do is basically look at all of your code and figure out, are there any issues with your code? Mostly it's dedicated to security, but it can also find other issues that your code might have. There are loads of tools you can use to do this. The one I'm chosen here today is Snyk. I really like the way it explains what the problems are you're facing, and it can even go as far as suggesting and automatically fixing your problems, I think. I haven't tried that bit out for myself yet, but I do like the explanation it gives for the problems. So we're going to go to Projects, and we'll go to Add Projects, and we're going to go to Monitor Public GitHub Repos. We'll go back here, and we'll just take the name of the project and the owner, and we'll add that repo and import it. And it will take a second to pick that up. So it's failed some of the imports, but that's okay. We're just going to use it as an example to see what we can find. So it's got some of the stuff. If I do a refresh, now it's going to show our project here. So this one's actually pretty good. It has these different levels over here that say how bad are the issues that we've found. So we've got 5 low, 2 medium, no high, and no critical. You can set stuff up in Snyk that alerts you if you've got critical errors and stuff like that. Which can be really useful because it's usually really big security problems. We click on this and we'll click on the code analysis, and then we can scroll through our list and we can look at all of the problems, and it will tell us the exact problem on the exact line. Look, it shows us our code directly here. So the MD5 hash, it's not using a strong enough hashing algorithm here to do this hashing. This is actually a really easy problem to fix. So it's immediately given us a way we could contribute to this project, and even that small change there can add really big value. These are all look like they're hash related, so would you not only be able to tidy up all of the problems the project has, but you've then improved the project in 7 different places. And that's really awesome in terms of contribution, especially like getting started. Some of these projects will have like hundreds, maybe even thousands of issues, so you'll be able to take your pick and go through and find stuff that might be easy to start with, might be something you've dealt with before, a kind of problem or technology, so there can be quite a lot to choose from. So for our next point, we'll jump back over to Visual Studio again. And what we're going to look for is how we can apply clean code techniques to a project. So really, clean code is basically making sure that the entire code base is easy to read and navigate. So making sure that methods and variables are clearly named and describe what they're doing. Making sure you have small functions, you don't have lots of indentation. There's loads of resources online that tell you what you can look for and how you can make code cleaner. Or you could go to the #1 resource, the book Clean Code by Uncle Bob. We're going to look through this project, and luckily I've already been through it for you, so I don't have to browse for ages, and I'm going to go into the JSON helper class. So this stuff is kind of okay. It's a little bit long, but it's kind of basic. We get to this function here, and suddenly we've got lots of indentation, lots of stuff going on. It's not super clear what's happening necessarily unless you spend ages reading through it. So what we want to do is we want to start pulling some of these out into their own smaller functions. So we've got lots of stuff going on. We've got some setup stuff here. This could come out to its own little function. That might not be worth it. We've got a whole thing here that's reading some JSON text data. That can be pulled out into its own function. So the rest of your code just needs to know that you've got some JSON data, or you've got a J token in this case. It doesn't need to know how you got it. So in fact, let's do this. So in Visual Studio, I can press Control- and extract a method. And we'll just call it get token data from input. We'll make it really descriptive. And also we can get rid of this bit here. So now this function is really easy to read. Get token data from input. Well, this is our token, J token here. So we know what the outcome is. We know what the input is. So we can basically read it in plain English at this point, what it's doing. We don't have to think about what goes into that to make this work. We've got some stuff here, some sorting for the JSON token stuff. So again, I can extract this into a method as well. Sort J token data. We don't need to know necessarily in this big function how it's done. We just want an easy to read set of steps so we can get an idea of what this function is logically doing. If we want to know how these things are done, we can go to the functions, which are at the moment kept below. There might be some extra consideration you want to give into where do these live? Do they belong here? Do they belong somewhere else? Are some of these things more global? Can they be used in other places and put in more of a shared space? We don't really need to worry about that for now, but you get this idea of how we start building up these readable steps so you can understand large amounts of functionality when they come together without having to read all of that functionality at once. And a big part of clean code, at least the way I like to apply clean code, really hinges on this feature of making it understandable for anyone. And I like to think if it's clean enough, someone could come in with no knowledge of C# and understand what it's doing, which makes projects, particularly open source projects, much easier to jump into if you're not necessarily used to the language so much, but you really like the project. One thing to note before you start doing some of this stuff, particularly if you're changing more than just pulling some functions out, is you probably want to apply some of the other stuff we've looked at so far. So particularly testing, but also things like performance testing and the static code analysis. Basically, when you're changing functionality that's already there, you want to make sure you're not breaking it before you change it. So for our next tip, something I'm a big fan of myself is looking at the DevOpsy side of the project. How does our project build? How is it deployed? Is it tested properly? That kind of stuff. So the backbone for that kind of thing really is the pipeline, the CI/CD pipeline you've got on your project. So the first thing we want to do when we're thinking about this is what kind of pipeline is there? Now, it might not tell you in the documentation what's going on. You might get an idea from some of the stuff in here. So this says Azure pipeline succeeded, so we know it's an Azure pipeline. If you're not sure, you can look at the project itself, look at the directories, and there might be some hints for what it could be. So GitHub, if you go into a .github folder, if there's a workflows folder, that will indicate it's GitHub Actions. There might be folders at the top. If there was one here saying Azure DevOps Pipeline, that would be pretty obvious. We've got one here called CI, which could either stand for continuous integration, or it might even be Circle CI, which is another DevOps tool. So we'll go in here, and oh look, we've got Azure Pipeline YAML files. So we know it's an Azure Pipelines DevOps process if we hadn't known from the tag before. So if we want to go into these, we can start having a look around and trying to understand what it's doing. So we've got some variables. We start by building it. We build the unit test, run the unit tests, and then it outputs an artifact. That's pretty standard stuff. I'm okay with that. We look at the release pipeline, and what have we got going on in here? We got some setup stuff here from the manifest, logos, some code signing stuff with a certificate, building another package on the side. It's doing a release build. It's building it for the Microsoft Store package and releasing that. It's pretty standard stuff, and really you have to be realistic with your pipelines. For this project, this is probably all it needs. There probably doesn't need to be lots of extra stuff, particularly as there's no, let's say, like architectural deployments. We don't have to worry about cloud services or, website releases and if they're stable or things like that. So because this looks pretty good, I'll have to give a bit of an extreme example for sort of something you could change in here. But after this is built and it's deployed to the Microsoft Store, you could have some extra automation in there to download it from the store, install it on a machine, run it, and do some UI tests while it's actually there and running. Bit of an extreme example. Maybe you could just have an extra stage in here for integration tests or something if you were to add those in or separate them out if they're already there. You really do have to be pragmatic with your pipelines, particularly when you have to think about what services they might interact with. If you've got a pipeline that's, say, deploying some stuff to Azure, then obviously you're touching someone else's development environment. It's probably not going to be so easy to just run that. But if you're making changes around that, you do have to think this might, impact cost or what the architecture might look like, those kind of things. So just make sure when you're doing a pipeline or a DevOpsy style change, it's like in line with what the project wants, or you might even want to start contacting some of the owners to say, hey, I really want to add this, but it might impact you in this way or that way. Is that okay? And they'll tell you if it's okay or not. And now we come to the final thing on our list, and that's a nice simple one. Do what you enjoy. And really, I mean that in the technical sense. So if you're working on a software project and you're really into a certain aspect of, say, the language, there's certain things programmatically you really like doing, to see if there's places you can fit those into the project. For me, I really like DevOps stuff, so I would go and look at some of the pipeline stuff, like I mentioned. If you were really into something, let's say design patterns, you might want to go through and see, is there a way I can fit design patterns in here? If you're really into scalability, you might see if there's ways you can break stuff down into services and sort of prepare the whole thing for maybe a microservices migration. It really depends on what you like. Just make sure that whatever you do, it actually adds benefit to the project. There's no point in doing something just so you can say, oh yeah, look, I've done this, it does something special, but it doesn't really benefit it. So just something you need to make sure of before you do something like that. So there we have it. 10 tips on how you can directly start contributing to an open source project, and with a few bonus tips thrown in through there as well. Don't feel like you have to start with some of these really big things, especially if it looks complicated. If you're new to open source or even new to like programming, don't feel like you have to start getting stuck in with some of this complicated stuff. There are loads of ways here that are really simple to get started with, so you can find small ways that you can contribute, and then over time you'll build your knowledge up, you'll build your confidence up, and you'll start being able to adding more and more. And just because a change is small doesn't mean it's not impactful. Hopefully you've enjoyed this video, and hopefully you've learned something too. And if there are any more ideas that you have on how people can get stuck into open source projects and contribute in other ways, let us know in the comments. I'm sure it will help a lot of people out. Thanks very much for watching.